Hey, so what we're going to do is talk about the phase changes of matter. So we know all about the three different phases. And we're going to do this by drawing on your notes. I hope that all of you guys already have a science notebook. It's usually a green book like this, and it has lines on the inside. This is what we're drawing. So it's going to take up the whole page like this. Um, when you got these books from school, I did not write science on there. I was expecting you to be able to do that. So if you don't have a book like this, then just do this on a piece of paper and bring it with you to class next week, and I'll get you a book just for science. I don't want you to mix science notes with other kinds of things. Okay, so you need to be sure that you've got a piece of paper for this, a pencil, and you also need a blue and a red marker or color pencil or crayon or something like that. So go get that, please. All right. So the first thing that we need to do is we're going to write phases of, phase change of matter. Okay. The phase change of matter. And there are three phases of matter that we know. We've got a solid. It's going to go up there at the top. A solid, a liquid down here, and a gas. We're going to make a triangle. Solid, liquid, and a gas. Now, we know what the particles are like in these three substances. When we start talking about a solid, we start talking about particles that are close together. If they're arranged in a pattern, it's called a crystalline solid. If they're arranged randomly, it's an amorphous solid. And then they're also moving and they're like vibrating. Okay. A liquid is when we've got, they're a little bit more spread out, not quite as packed. And then I'm going to use like some arrows like this to show that they're moving and kind of fluid around one another. A gas, on the other hand, are much further apart and they're like choo in all different directions. Okay. Maybe I'll erase that one to make them look like they're more far apart. Yeah. But gases, they're much more spread out. Okay. Now, anything on the periodic table, those pure elements, they're going to exist as solid liquids and gases. All right. And so really what we're talking about as they're moving from one phase to another, there is a transfer of thermal energy. Okay. And we're talking about this in design as well. So thermal energy can be transferred from one object to another. And when that happens, when a solid gains thermal energy, enough of it, it's going to turn into a liquid. When a liquid gains thermal energy, it's going to turn into a gas if it gains enough of it. And the same can be true in reverse. If a gas loses thermal energy, that means it's going to get colder, and it's going to, if it gets cold enough, then the material will change into a liquid. If the liquid gets cold enough, then it's going to go and change into a solid. Now, the state of matter that we have the most experience with is water. Okay, so phase change of matter, and then let's talk about water specifically. All right. So if we think of water as a solid, the water that we know as a solid is ice. The water that we know as a liquid we call it water. And the water as we know it as a gas is called water vapor. Water vapor. Oop, I should spell that right. V-A-P-O-R. Water vapor. Okay. Now it's best if you are following along with me, and but if you need a moment to draw this, then give this video a pause and give it a draw, okay? All right, solid, liquid, and gas. Now, we're going to talk about those processes between between solid, liquid, and gas, and liquid and things like that as it's changing, the process of change. Now, let's start with a solid. If we start with a solid and it changes into a liquid, that has a special name, melting. All right. When a solid changes to a liquid, we call it melting. When ice melts into water. Okay. Now, the opposite is true when we go the other way. When we say if a liquid changes into a solid, the word for that is freezing. Okay. Now, pure substances have temperatures where this happens. And so for water, 0 degrees Celsius is the magic temperature for this to happen. Above 0 degrees Celsius, then we've got melting that happens into a liquid. Below 0 degrees Celsius, we've got freezing that happens and the water turns into ice. So 0 degrees Celsius is like that magical level, that magical temperature where those two things are going to happen. Now, this is true for water. Different substances have different melting points. And so we call this right here a melting point, MELTING point. We call that a melting point. And I'll just draw a little arrow there. All right. Different materials have different melting points. All right. For example, gold. Gold is not going to melt like at 2 or 3 degrees Celsius. It's going to start, water is going to start turning into a liquid. But gold does not have a melting point of 0 degrees Celsius, right? It's a solid. So the melting point of gold is going to be a very, very high melting point, all right, a higher temperature. All right, if we go from a liquid to a gas, that's going to be called vaporization. A liquid gaining enough energy to turn into a gas is called vaporization. And there are two different kinds of vaporization. So I'm going to draw that off of here. There is evaporation, which you know about when you learned about the water cycle. Water evaporates off the surface of like the ocean, of pools, of bottles of water. Your sweat evaporates off of your skin. All right. So evaporation is one type of vaporization, and then also boiling. Boiling is another type of vaporization, and that's when, if you think about like a pot of water, that heat source at the bottom, the water is getting so high, and at a certain point, the water is going to turn into a gas. And because that gas is less dense, it's going to bubble up to the top. Now, water also has a certain boiling point, 100 degrees Celsius. All right, so the boiling point of water is 100 degrees Celsius as long as we are at sea level. It changes with altitude, which we'll learn about. But those are two words for vaporization, when liquid gains enough thermal energy to turn into a gas. The opposite of vaporization is called condensation. Condensation. Condensation, if you've experienced condensation on the outside of a cold soda can, the soda can isn't leaking water magically. When there is right now in your room, when you're breathing, one of the gases that you're breathing is water vapor. Water vapor is actually in the air that we're breathing, along with nitrogen, carbon dioxide, oxygen. And so whenever that water vapor, that's a gas, hits that very cold can, it loses thermal energy, and that water vapor gas turns into water droplets that's on the can. So that's condensation on your can. If you've taken a really hot shower, some of that water that's coming out of your hot shower is evaporating into the air into your bathroom. And when it hits things that are cold, like the wall, the doorknob, or the mirror, then it's going to condense into little tiny water droplets. And so that's why you see the condensation on the mirror after a hot shower. Clouds are an example of condensation. Closer to the surface of the earth, the air is warmer. Evaporation happens, and then we've got water vapor inside the air. But as that air rises into the atmosphere, it gets colder the higher up it goes. And so when it gets colder, it loses thermal energy and changes back into water, little tiny water droplets that are so tiny, they're floating up into big clumps in the air. Now, when we revert this back to the water cycle, when condensation happens in the air to create clouds, those little tiny water droplets start to stick together. And when they get too heavy to continue floating, they actually fall down as precipitation, as rain. All right. Now, so these four, I am assuming that you've heard of these four phase changes of matter before. I know that in the past grades, you've learned about the water cycle. So these four things are not unusual to you. Now, there are two phase changes that are a little bit more unusual. And so that is the phase change between gas and a solid. Okay. It means that it's gained thermal energy so quickly that the solid turns directly into a gas, skipping that liquid phase. It also means that a gas can lose thermal energy so quickly that it goes straight to a solid. All right. So let's see here. If I go from a solid to gas, all right, a solid to a gas is going to be called sublimation. Sublimation. Right? An example of this would be dry ice. Dry ice is, it looks like ice, it's white and it's really super cold, but it's actually carbon dioxide that is so cold that it is a solid. But when we bring dry ice and put it on the table, for example, it's gaining a lot of thermal energy very quickly and it changes straight to a gas. It goes from a solid dry ice to a gas that's carbon dioxide. This can happen as well with water. For example, if you were to put ice in your freezer and just leave it there, over time, some of that ice, even if the freezer didn't break down, some of that ice will sublimate into gas, and those ice cubes will get smaller and smaller in the freezer over time. All right, so it is possible on a small scale, but it's not something that you can see really happening with water. So when we go from a gas to straight to a solid, the opposite of sublimation is called deposition. All right. And a situation that you might see this is, let's say, well, first of all, let's talk about condensation again for just a moment. I'm sure all of you have been somewhere where it's been kind of cold outside and you go, and you can see your breath. What you're really seeing is the condensation of the water vapor that was in your breath, right? So that water vapor is warm inside your body, and when you breathe out, it cools and loses thermal energy and turns into little tiny water droplets that you see. It looks like a cloud. Well, if it's really, 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 really cold, it's possible for you to go, and instead of turning into like a little cloud that dissipates away, it turns into like these ice crystals that fall to the ground. I've actually never experienced that myself, but there are YouTube videos about it, and it's a possibility. All right. So sublimation and deposition are opposites of one another. Okay. All right. Now comes the needing of the red and blue. All right. We're gonna make a key. So we're going to use red to show a gain in thermal energy. Gains thermal energy. When particles gain thermal energy, that means that their temperature increases. They move faster, the particles move faster, and they spread out. All right, let's think about blue. Blue is going to be the opposite of this, a loss of thermal energy. I'll say lose thermal energy. That's a decrease in temperature. All right. It moves, the particles move slower and they get closer. The word for this is condense. Condense. So particles getting closer is condense. Particles spreading out, the word for that is expand. Might as well use the science vocabulary if we've got it. All right, so let's identify which of these arrows should be red or blue. So let's think about this. So freezing and melting. Which one of these is an example of a gaining of thermal energy? If a solid melts into a liquid, it is gaining thermal energy. And you can see from the pictures that the picture, we've got it more spread out. The particles are moving faster. If I take the temperature of a solid, it's going to be colder than the temperature of the liquid. It has increased. All right. Which means freezing is the opposite. Freezing is the loss of thermal energy. So if a liquid freezes into a solid, it has lost thermal energy. Which one has lost thermal energy from a liquid to a gas, vaporization or condensation? Condensation is a loss of thermal energy. You can see they're all spread apart and they condense. So that's condensation. The opposite of condensation is vaporization. So that shows a gain in thermal energy. The particles get faster and they spread out and it expands. If we're looking at solid and gases, which one of these would be a gain in thermal energy? Sublimation would be a gain in thermal energy. And you can see that because from a solid to a gas, the particles are spreading out, they're moving faster. The temperature of a gas as water vapor would be a higher temperature than a solid. Deposition is the opposite here, where you go a loss of thermal energy. All right. So these are the phase changes of matter. I want you to be sure that you save these notes, bring them to school when we have science, to make sure they're in your science notebook. Always be sure you've got a title and a date. All right.